Hello. First of all, I want to give a shout out to the whole Gnosis crew for this amazing event, and thanks for having me. I'm going to talk about how to build whatever with Celestia underneath. First, a few words about myself. I'm Ismail Khoffi, co-founder and CTO of Celestia Labs. I started my crypto journey roughly 10 years ago, basically in academia at EPFL at the Decentralized and Distributed Systems Lab. I was also part of the team that launched the Cosmos Hub. Enough about myself. This is the things I want to cover today. Introduce Celestia and modularity for those that are not familiar with these concepts or the project. I want to show you how today, like a few ways how you can build whatever with Celestia underneath today, and highlight some like early community and a little bit go into support structures, and at the end, Q&A. So what is Celestia? What is modularity? When the first blockchains came about, when Bitcoin was introduced, the paradigm was that every chain, like every application, has its own chain essentially, right? And every chain does everything. Like it does consensus and the business logic, the state machine, the execution of that business logic. So in Bitcoin, that application was payments, obviously. And there was like Bitcoin script as a very minimal execution environment, and it used Nakamoto consensus. And then Ethereum came about, revolutionized having this notion of like a world computer where you can execute any program, essentially. Now uses different consensus, Gasper consensus, but they're monolithic in the sense that both these chains and all the chains in that era basically did everything at once, the business logic and the consensus, right? The only way to launch a new dApp back then was you basically forked Ethereum, then Namecoin was introduced, and so on and so forth. So before the notion of modularity or modular chains or modular blockchain networks were introduced, there was this seminal paper by Vitalik and my co-founder Mustafa and Alberto Sonio. The motivation here was actually to scale Ethereum and to make light clients more secure. And Mustafa took this idea and spun it even further and said, like, what if we, instead of trying to make sharding possible and so on and so forth, what if we can introduce a layer one that does only the most basic things, which is consensus and data availability. In the previous paper, there was this like data availability problem formally explained. There was a new mechanism introduced called data availability sampling, which makes light client more secure in the sense that they can verify that data was published. And this paper says like, okay, let's take this and make it its own chain. And so the core idea, as I mentioned, is instead of chains doing everything, as mentioned before, you split it up into like different layers, into different chains. So you have like the data layer or the consensus layer that only like focuses on that, and the execution, the business logic now is in a different chain, like in a roll-up chain or more generalized in an execution layer. So basically these things that lived in one chain are now decoupled into multiple chains essentially, into like multiple specialized layers. Conceptually, as I'm repeating myself a bit here. Conceptually, monolithic chains, like they have consensus and execution in one chain. Sometimes, if there's like Ethereum flavor or like Solana, they come with a virtual machine such that you can run smart contracts on top. In modular blockchains, though, you have a data and consensus layer and a large zoo of like different execution environments that can also be EVM, but they can also be your own flavor, something highly specialized. They can be like a Cosmos SDK app. They can be layer 2s, layer 3s, using your favorite Ethereum stack or whatever you can imagine. So I keep saying these words, modularity and settlement execution layer. I briefly want to go into detail what these are. What are the things that every chain, every monolithic chain does? They are execution, settlement, consensus, and data availability layer, which in the modular stack get decoupled or decomposed into separate layers. So what is actually consensus? Like consensus in its very basic form is just ordering of messages, arbitrary messages. The consensus layer does not inherently need to know what these messages are. They're basically blobs, right? Opaque blobs that get ordered and reach consensus on that order. The data availability layer, on the other hand, ensures that the data that was published, you can verify that it actually exists in the network and was published. So these arbitrary messages that get ordered must be available to you such that you can verify they were published. And then the execution layer, a brief detour to the Bitcoin white paper. These ideas are not entirely new. It's just we didn't know how to do a verifiable data availability before data availability sampling. But even in the Bitcoin paper, this notion of ordering messages, timestamping them, and having them widely published was introduced. So what is data availability sampling that I also mentioned before? Data availability sampling is a technique that allows you to verify that the block was published without having to download the whole block. In fact, you download only a very small portion of that block, right? You can download less than 1% and have almost 100% guarantee that the whole block was published. And why does this matter? It matters because for the execution layer, you take this data, these arbitrary messages that got ordered, and they get executed, right? They are the actual, the state transitions actually happen on the execution layer. Very simple example is account balances and transfers. You do a transfer, account balances get updated, right? That happens on the execution layer. So I also mentioned, you may wonder if it's arbitrary messages that get posted on the data layer and the data layer is not aware of what these are. You might wonder, how is it guaranteed that the transactions that are posted or the blocks that are posted on the data layer, how is it guaranteed that they are valid? There's roughly two approaches here. One is what is now called optimistic rollups, basically via fraud proofs. So you post the data, you assume that the block producer or sequencer of the rollup is non-malicious for most of the time, but in case they post an invalid block, every node that downloads the whole block can easily generate a fraud proof that then even light clients or light nodes can then verify. There's a different approach, which is validity proofs, where you also post some cryptographic proof that the state transitions were valid. And this is often called ZK rollups because you post ZK proofs for validity. So you have this, you have different trade-offs, obviously, but you have the same guarantees that the transactions are valid, but you post the data somewhere else. Another layer that I mentioned is a settlement layer. It's essentially a specialized execution layer that does bridge between different other execution layers. Very simple example, Ethereum is used as a settlement layer, obviously, for many rollups today. Again, using fraud or validity proofs. So what is a modular blockchain? A modular blockchain is a chain or a network that outsources at least one of these tasks, right? Like it outsources at least execution, settlement, consensus, or data availability. It doesn't handle that component itself. And if you think about it, it's actually very similar to how the web evolved early on. When you, in the 90s, when you wanted to host a website, the only way to do so was via a physical server. And similarly, as I mentioned before, in the crypto ecosystem, the only way to deploy your dApp was to launch your own chain using your own consensus. In the developing web, you could use hosting providers, shared hosting providers like GeoCities. I don't know, maybe people are old enough to remember these things, but you were basically tied to like choices that these hosting providers provided for programming languages like PHP or Perl even, using some CGI interface. Similarly, in the crypto space, the idea came to existence of this like shared smart contract environments where you could like deploy your application using like a smart contract blockchain, like Ethereum, Near, Solana, and so on. In the modern web today, websites run on virtual machines. Like they share physical machines, but they run in virtual machines. And similarly today, we basically see this evolving in the crypto ecosystem as well, like in Ethereum and in Celestia as well, is dApps run on application-specific chains that share consensus layers, right? Like Ethereum rollups, Celestia application, like every application is built on Celestia, that's true. And we see that this paradigm is used more and more in the modern crypto ecosystem. So what is Celestia? Celestia is basically the first modular blockchain network because it's stripped down to its core components. It is a chain that only handles consensus and data availability and is specialized for that. And execution like happens completely somewhere else. There's even no settlement layer. There's a very minimal state machine that for the chain to function. So there's like transfers, proof of stake, nothing else. You might wonder, like, okay, this sounds all fine and like from a theoretical point of view, what are the benefits of that? So in the last cycles, so to say, the way people thought about scaling were either like super complex, or many new chains came about and said like, okay, we're gonna fix scalability. Here's a solution. We're gonna do something better, like a new virtual machine. We do parallel execution, or I don't know. They promised better scalability, and what happened there is basically you had to copy this whole ecosystem that existed that already existed in like the established chains, and then either these new chains fail to gain traction and like become less relevant, or they are actually used a lot, but then they hit scalability limits and they get congested. Transactions either get expensive or you don't get them included in the blocks and have to retry a lot. So and that continues, like that used to continue, and we want to basically break this cycle using modularity, because we basically remove the main bottleneck from the layer one, right? Like you move that by moving execution out of the layer one and having like specialized, dedicated compute in the rollup layer instead, that makes it possible for actual scalability to happen in the sense that, this is like specialized layer that execute for your dApp specifically in the way you want, in the way you need it. And there's also a nice property that with this, theoretically, you can have like massive blocks, because the more rollups exist, the more light clients there are, the more difficult you make it to make what is called a data withholding attack, because light clients can actively contribute to the network by making block reconstruction possible as well as a fallback. So this is important if you really want like mass adoption and everyone using like if it actually spills to the real world, as Martin said before, then you want a system that can actually scale beyond just one layer one, on like one world computer. You may wonder, right, like that's also, like everything is converging in that direction these days, right? Like when we introduced this like data layer and the notion of modular blockchains, it was like first frowned upon and like not fully understood. But today is like everything's converging, and then like even in Ethereum, you have obviously blobs and the last upgrade. You may wonder like why is it even necessary? Like if my favorite layer one does this already, I think having a specialized layer that only does data availability is still relevant because of the specialization, it's still more cost efficient. Your application is not competing with other applications for settlement. It's purely data availability. So there's this page from a team called Numia, datalenses.zone, where you can calculate for your application the cost savings even after the last Ethereum upgrade. So besides cost saving and scalability, you get a lot more choices, right? Like you can mix and match these different modules like Lego pieces together. Of course, that also can bring more complexity, but it doesn't have to and can be abstracted away. But like, for example, you can use Celestia today as a building block to build your Ethereum layer 3 or layer 2 by using Ethereum for settlement and consensus and get like very high security guarantees there and use Celestia purely to post your data. And your chain does only do the like highly specialized execution that you need. And there's other, right? Like your chain can also be a settlement layer for other chains. Your chain could be a rollup that uses such a settlement layer, or your chain could be what is called a sovereign rollup that is basically launching your own chain without the burden, without the overhead of launching your own proof-of-stake network. It's more like launching a Cosmos zone, but you don't have to launch a proof-of-stake network. So what are the options concretely today? You can, like, I was told that the audience here will be very Ethereum focused, so you don't have to, if you don't want to, you don't have to learn anything new. You can use your favorite, like, EVM stack, write your code in Solidity, for instance, use Arbitrum Orbit or Optimism's OP stack to build on Celestia today. You may wonder, wait, if I use these Ethereum stacks, do I still have to interact then with my layer 2 or layer 3 directly with Celestia? Yes and no. You have to post data to Celestia, but for the security and like to verify that this data was published, you only interact with a smart contract on your favorite EVM, like Ethereum or Base or whatever. Or Gnosis chain could also be like there's a project from Succinct called Blobstream X that makes it possible to basically have a light client of the Celestia chain on the EVM chain, and you have like ZK proofs, and you only interact with that smart contract. So I think the most convenient way today to launch your own chain on Celestia or build whatever with Celestia underneath is you use a rollup as a service provider. This literally, you can think of it as like AWS, but decentralized in the sense you have the same convenience, one-click deployments. You just choose a few options, and this is perfect for like teams that are early and want to like iterate quickly, launch a test net, and also what you get here is the full package. You get like RPCs, block explorers, oracles, indexers, and so on and so forth, depending on the rollup as a service provider. So again, when we thought about this early on, it sounded like a pipe dream almost. But today there's like a whole zoo of these rollup as a service providers. And I picked one here just to show you how it looks like. This is the Conduit landing page. And if you look at their page, you can choose your stack, like Arbitrum, OP stack. You can choose your settlement layer, mix and match, Ethereum L1, base layer 2, Zora mode. You can even choose your data availability layer. You're not forced to use Celestia, obviously. And you can mix and match as you want. Click continue. A few minutes later, your chain is running. And costs like, on testnet, costs like $50 a month. Very, very convenient. Another option that I mentioned before, if you value more sovereignty, you want your own chain that doesn't need to care about like a settlement layer for fork choice rules, or you don't care too much about like having a high security settlement layer, for instance, like a gaming rollup, or there could be many reasons having the freedom, or you don't need that much security but want to save costs. A sovereign rollup is a very good option. Today there's like 2 ways to build. This is Rollkit. We're building this in-house currently still. It basically allows you to, it's a drop-in replacement for Tendermint, so it allows you to build any ABCI app, including any Cosmos SDK app. But like with ABCI, you're not bound to the Cosmos SDK, but it's the most convenient way. Yeah, this is a way to build a sovereign rollup today. And similarly, Sovereign, a different team, is building like more focused on ZK rollups again, but is building a sovereign rollup stack, sovereign SDK as well. And if you want to be more experimental, you can also there's also teams building what's called Eclipse, for instance, which is Solana on Ethereum and Celestia. Celestia for data availability, Ethereum for settlement. And there's other, like there's many more. If you want to be more experimental, care more about privacy, performance, whatever, like you can innovate in these execution environments without having to deal with the consensus and data availability part. So support and early community. I think the go-to place is our homepage for, this is, I think, celestia.org/build. There you can like get any, like if you're a block explorer or a team that wants to build something, you'll find any information there. It's a good entry point. Obviously there's docs. They are all open source, community maintained to some extent. If you find a typo or a bug or something is missing or you want to improve them, you can also, they are all on GitHub. They are also for different categories. Obviously, this is more a developer, like for developers, this is the most relevant go-to place. And also there's like already, we launched like the Celestia network launched like around half a year ago. There's already a growing community of actual chains that are deployed. I think it's maybe too small to see, but like this is Selenium, a Celestia-focused block explorer. There's also a leaderboard for rollups, and the leaderboards you can sort by like how much data they post today. And there's not only rollups, there's like a whole zoo of infrastructure that makes, that tries to remove the complexity that is also introduced by all these choices. Besides the rollups, there's the mentioned rollup as a service providers. There's a bunch of rollup frameworks that you can use to build. There's shared sequencer networks where you can like share a sequencer to like, with other rollups to post your data. Settlement layers, obviously. Bridging, cross-chain, like, yeah, obviously wallets, block explorers, and so on and so forth. This is like an early snapshot. I don't think that's complete anymore, but it's an early snapshot of our community. And as I mentioned, there's like new virtual machines and new execution environments coming as well. So I realized I talked much faster than I did in my dry run, but I can spend a little more time on Q&A then. So what is next? I think the focus for us as like the Celestia Labs team and as a community is to enable massive blocks. We want abundant block space because if you think about it, if we actually want to serve all the rollups and especially like all these AI projects that are coming to existence or even just payments, if the payment networks are worldwide and used by everyone, you need abundant block space for this to be possible. And we're targeting, like, our credo is like to have 1 gigabyte blocks eventually. But this year we wanna commit to getting at least like 32 or up to 100 megabyte blocks. And obviously a big focus as well is to improve the developer experience, right? Like the docs can always be improved, the APIs can always be improved, and that's a huge focus because when you build these things, and this is completely new, you don't have any feedback, right? You're building a product that you can like try internally, you can try it with like a few projects that are piloting, but like now we have actual users, now we're getting actual feedback, and we're thinking more of our APIs and so on, like as a proper product, and this, like, we're getting very good feedback, and we want to improve the developer experience as much as possible, such that it's like super easy to launch your chain, like easier than like deploying a smart contract. Thank you. That's it. Thank you. Go check out Celestia.org, Biddle, and there's time for Q&A now.
So we invite any questions that you have for Ismail. Does anyone have any questions about Celestia? We have one over there. Thank you.
Hi, my name is Jan from Oak Security, and I have a question. Like you talked about gaming, but I think this is so relevant, and I think it's so exciting what you built for institutional institutional finance builders. Are you targeting those, or like what's your take on those?
I mean, we're not specifically targeting anyone. It's like the credo is build whatever. So it's like everyone should feel comfortable building on Celestia. But can you elaborate why this is so relevant for institutional?
Like, so my experience with them is that they need they don't want to get into the technicalities of consensus and data availability, but still, from a regulatory perspective, they need a lot of control on the settlement side. So they need to make sure that they basically, have kind of admin controls around the settlement layer.
Yeah, I mean, that's certainly true. It's also true for DeFi projects. They prefer to launch as their own chain, but they want a decentralized sequencer network. I guess we're not targeting them specifically because, like, I'm not aware of like big projects or projects in general approaching us with this regard. But there's obviously a very good use case, and if you know someone, please put me in touch with them, and I'm happy to help.
Thank you. And do we have any more questions? Yep, one over there. Thank you.
Hi. Thank you for your talk. Really insightful. So I understand that Celestia in general has a lot more pieces with the modular architecture. But from your perspective, for just the data availability part, what's like maybe 1 or 2 things that you would say stands out in comparison to, say, EigenDA?
I mean, we have data availability sampling and like live docs, and you can like there's chains building. I think EigenDA is actually quite different from the infrastructure, but Yeah, I think what stands out is data availability sampling. You can verify, like I didn't put enough emphasis on this on the slides, but everyone can verify that the data was published through data availability sampling. And we favor, or we are big champions of like decentralization, but decentralization also means that you can everyone can verify the chain, and and verify that the data was published is part of that. That's the key thing of a data availability layer.
Well, thank you so much, Ismail.
Thank you.
It's been a pleasure.
Bye.